Okay, so what happens if you have a negative exponent? We haven't seen that before. All right, let's say you have something like x to the third over x to the fifth. Well, the rule for quotients says that's equal to x to the 3 minus 5, right? Well, what's 3 minus 5? Negative 2. Okay, so keep that in mind. Remember, subtraction is not commutative, so it makes a difference if you go 3 minus 5 or 5 minus 3. And you have to take the top one, the numerator, the exponent in the numerator, and subtract the exponent in the denominator. Okay. But what does this really mean, x cubed over x to the fifth? Well, x, in the numerator, x, in the denominator. Each of those x over x's, they're just a 1, right? And so in the numerator, you can think about canceling too. Like you might like looking at it better that way. You're canceling, 3 of the x's in the top with 3 of the x's in the bottom. And so you get 1 in the numerator over x squared. So these two things have to be equal to each other. So the rule says this. It says if you have a to the negative n, then that's 1 over a to the nth power. Okay? So a negative exponent means it goes in the denominator. Unless it's already in the denominator, and then it goes to the numerator. But we'll get to some of those, I'm sure. Okay? So this is the rule. That's what a negative exponent means. Now, sometimes we like the negative exponents. We're fine with them. But a lot of times they're going to say, write your final answer with positive exponents. Okay. So let's look at some examples. Write each of the following quotients with a single base. Do not simplify further. Write answers with positive exponents. I don't know why my thetas are so little. Now, it's little. Theta cubed over theta to the 10th. Now, you might not be used to seeing a theta. That's a Greek letter. So I'll spell it out. It's theta, spelled like that. The more math you do, then the more Greek letters we get. But you're all familiar with, the delta variant and the omicron. Those are both Greek letters. So anyway, all right, back to this. So 10 cubed over 10 to, theta cubed over theta to the 10th power. You can use the quotient rule that says that's going to be theta to the 3 minus 10 or theta to the negative 7. That's fine, but we have to write our answer with positive exponents. So that would be 1, sorry, it's bouncing, 1 over theta to the 7th power. Okay? Now, if you're up here and you're just saying, I was just going to cancel 3 of those with 3 of those and have 1 over theta to the 7th, that's fine. Okay, same thing. All right. Now, what about the z's? Well, in the numerator, I'm going to have z cubed, because I got 2 plus the 1 there, right? Z squared times z is z cubed, over z to the 4th. Again, you could write that as z to the 3rd minus 4th. I don't like the way that sounds. Z to the 3 minus 4. That's z to the negative 1, and that's 1 over z. Or you could have just canceled right from there and gotten 1 over z. So that's fine. All right, and now we have that kind of weird base here, negative 5t cubed, but they're the same. So I'm subtracting these exponents. It's negative 5t cubed to the 4 minus 8, or negative 5t cubed to the negative 4th power, but we don't want negative exponents. So the final answer is going to be 1 over negative 5t cubed to the 4th power. And that's the way we would write it. We have to have those parentheses. Okay.